Hi, I'm Tyler. We're going to be doing some examples today on the Fisher effect. Just remember, notation might be a little different than your professor uses, so check that before you turn your assignments in. So in the last video, we found that even though these two cases have different nominal interest rates, they have the same real interest rate of 10%. So now we're being asked if there's a tax rate of 25%, in which of these two cases do you pay the most taxes, even though they have the same real interest rate. So what you do is you find out what your nominal return on this investment is. So you initially invest the $1,000, and then in case 1, the interest rate's 10, so your total return is 1,000 times 10%, which equals 100. And then in case 2, you have that same deposit of $1,000, but there's a 20% nominal interest rate, so you multiply it by 20%, which gives you $200. Now that we know what their actual nominal return is, we have to figure out how much they take in taxes, basically. So you take the 100 in the first case, and you multiply it by 25%, and you get 25. So in the first scenario, or the first case, you pay $25 in taxes. In the second case, you take the 200 that you get, multiply it again by 25%, and you get 50. So even though the real interest rates are the same, you pay twice as much in taxes nominally. That's important, it's nominally, in case 2 because of the inflation. Alright, so we found out in the last example that in case 1, the taxes paid were $25, and in case 2, the taxes paid were $50. Now, it asks us, with that 25% tax rate in these two cases, to compute the after-tax nominal interest rate and then the after-tax real interest rate in each of these cases. So, for case 1, to get the after-tax nominal interest rate, which is what you actually get after taxes, you take the nominal interest rate, which is 10%, and multiply it by 1 minus the tax rate, which is 25%. So you end up getting 10% times 75%, and that is 7.5%. So in case 1, the after-tax nominal interest rate is 7.5%. Now to find the after-tax real interest rate, which is, we use this formula down here, which says that you take the nominal after-tax interest rate of 7.5 and subtract inflation, which in this case is 0, and you get 7.5% again. So since there's no inflation, the nominal interest rate is the real interest rate in this case. So now we do this again for case 2, and to find the nominal interest rate is 20%. Again, we're going to multiply it by 0.75, that 1 minus the tax rate, and you get 15%. So since there's the higher nominal interest rate in case 2, the after-tax nominal interest rate is higher. It kind of makes sense. So to find the after-tax real interest rate, we again use this formula, but we take the 15% and subtract inflation, which is 10% in this case, and you get 5%. So we see here that inflation basically causes the after-tax real interest rate to be smaller in cases with higher inflation, basically. So case 1 didn't have inflation, so the after-tax real interest rate was no change from the nominal interest rate, but in case 2, that 10% inflation drove it down to 5%, so you're effectively getting less money back on your initial deposit. I hope that helped with the Fisher effect. If you have any other questions, leave a comment on the video or come down to the Econ Tutoring Center at BA 211. Thanks.